Okay, so shortly, let's see how we take the norm of a complex vector. So this is the general formula for a norm of vector. You can see that we take the square root of the first component raising to the power of 2 and etc. and etc. Now we are working on the complex plane, so if we have a complex number z equals a plus bi, when we are taking the value of this, the norm of this squared of this number, we need to take the coefficient of the real part squared and the coefficient of the complex part squared. So let's see how it goes. So let's take a vector. For example, look at this vector. We have this vector half I divided by 2, 1 plus I divided by 4, and etc. in C4. And let's see how we calculate its norm. So each component, we are going to take its value squared. So we're taking half. This is just normally taking the squared. And when we're taking the I divided by 2 squared, we are taking half squared. So we get 1 divided by 4. Now, when we take this one, we will take 1 divided by 4 for the real part, square it, and for the complex part, again, 1 divided by 4 is the coefficient for I, so again, we're taking it to squared, and we're just getting a 1 divided by 4 squared 2 times, so we get 1 divided by 8. And for the last one, 1 minus I, again, the same thing, just with the minus right over here, and we get this value. Now, because the minus get into the squared, we just getting the same. So when we calculate it, we sum it all up, and then in order to get the norm itself and not the square, we are taking the square root, and we're getting a square of 3 divided by 2. So here we are, we took the norm of a complex vector, remembering how to look on complex number and how to take their norm. And that's all what I wanted to show you now, how to calculate the norm of a complex vector in the complex space, what is called. Thank you very much, and I think that's it for now.